Okay folks, this is a quick tutorial on how to do this type of a logic gate problem. We have question 23 from the 2017 HSC paper here in front of us. If you don't understand how these gates work, you might want to go through the information that happens on the Exchange page before this problem. But basically we have on this page this table here. Now this is called a truth table. So just so you know a little bit of the terminology. Our truth table, and up the top here we have our logic gates in our circuit. And we're going to try to work out, given the inputs A and B that are listed in the table, what our output Z will be. So you need to understand how these gates work. We know that our AND gate, as per the tuition that the tutorials that I had before this this video, that an AND gate is like two switches in series. So you need two ones at the input. I need a 1 here and a 1 here to make a 1 at the output. Anytime we get a 0 arriving at this input, either on this side or on this side, or two zeros, this is going to be a 0. Okay, so you just got to remember that for this circuit to switch on, because we have our AND gate as the last stage, you need two 1s appearing here, here and here. Two 1s coming in, otherwise it's always going to be 0. So as soon as you get a 0 arriving at this input to this gate here, you know your Z is going to be a 0. So that might be a bit of a shortcut to your working out process. Anyway, let's get into it. A0, 0. So what we can do is we can grab our pencil and we can write a 0 there and a 0 there, and that 0 is also going to travel up to this NOR gate and give us a 0 there, and this 0 will travel down to this NAND gate and give us a 0. And these two gates, the NOR gate is just like an OR gate with the output changed to the opposite of what it would be. So if it was a 1 coming out of the OR gate, the 1 will turn to a 0. So you just got to imagine an OR gate that has a NOT gate at the output that changes the value to the opposite of what you'd expect. Failing that, you've just got to remember how this gate behaves with certain inputs and outputs. But if you think of it in terms of an OR gate, you don't need to remember a different gate. You just need to remember it's an OR gate, but the output will be changed. So we know with our OR gate we need a 1 at, if it was an OR gate, we need a 1 at either of the inputs to make our output a 1. But now we know that because there's no 1s, if it was an OR gate, the output would be 0. But because it's a NOR gate, that 0 turns into a 1. So we've got a 1 happening here. So now we need another 1 if we're going to switch this Z on. So if we look here, we know that with an AND gate, if it was an AND gate, and it's actually a NAND gate, but if it was an AND gate down the bottom here, we would need a 1 and a 1 to make a 1 happen. But because we've got zeros happening, if it was an AND gate, we'd have a 0. But that 0, because this is a NAND gate, it's got that little circle there. You can see this little circle happening here. That inverts, changes zeros to 1s or 1s to zeros. It flips them around. So that gives us a 1 here as well. So we've got a 1 and a 1, and this is on our NAND gate gives us a 1 output. So that's our first line of our truth table. So you need to follow through each time. The only way you're going to be able to do these problems is understand how these gates work. So you need to look at the information that comes before this video if you're not clear on how that happens. And then hopefully you will understand this type of question. Okay, now we have the second line of the truth table, which is a 0, 1. So our A is a 0 and our B is a 1. So that 1 travels up to this gate here, gives us a 1 here, and that 0 travels down to this and gives us a 0 here. Okay, so our NOR gate has a 0 and a 1 input, and we know that if we have a 1 coming in on our gate here, if it was an OR gate, it would switch on. So it's going to switch on, but because it's got an inverter on the output, that's going to give us a 0. So we already know that Z has to be 0, because once you get a 0 coming in an AND gate, you need both of them to be 1. So we can straight away say that's 0. But we will do the other gate just to see what happens here as well. We've got a 0 and a 1, so if this was an AND gate, this would be off, but because it's got an inverter on the output, we flip it round to a 1. But we still end up with the same result, which is a 0. So that's our second line of our truth table, and we can rub out our 1s and 0s. And then the next line, we have a 1 at A and a 0 at B, and that 0 travels up to here, and that 1 travels down to here. And we've already said if we get 1 coming in, if it's an OR gate, it would be on, and therefore it switches off. And here, we know that we need 2 1s if it was an AND gate to switch on, so it's going to be 0 if it was an AND gate, but that switches to a 1. But straight away we know as soon as we get a 0 arriving at this AND gate, we're going to get a 0 state at the output. And that's a 0. And then finally we just have our last row to go. So you just have to be very systematic about this and certain about what happens with each gate. And then finally we've got a 1 and a 1. So we've got 1. Oh, we better switch our pen back on. We've got a 1 here and a 1 here. And therefore we've got 1s arriving at all these gates. Now 1 and a 1 means that if this was an AND gate, it would switch on, give us a 1, but we've got an NOT gate at the output, so our 1 becomes a 0. So straight away we know we've got a 0 here because we need 2 1s here. And then we've got 1 1, which means this switches on, which means this switches off. It's all 0s, and we end up with a 0 state there. And that is your truth table completed. I will do another one of these questions, but the only way you can do this type of question is to fully understand how each of the gates works. Once you understand how an AND gate and an OR gate works, as well as a NOT gate, you'll understand how a NAND gate works and a NOR gate works, and it might also be a good idea to understand the exclusive OR gate as well. And all of that will be covered, or has been covered, in the information that happens before this video. Anyway, I hope that's helped, and give it a go. Have a go at doing some of these types of questions. Thank you.